Today's lesson is balancing chemical equations with polyatomic ions. So let's start off. I have copper phosphate plus sodium sulfate leads to sodium phosphate and copper sulfate. Now, this can look like a very imposing problem to solve at the face of it if you think you're going to list out all these atoms. However, with polyatomic ions, since they stay the same on both sides, PO4 is always with another PO4, SO4 is always with another SO4, we can treat them as individual units. So when I'm writing this down, I'm going to write copper and then phosphate instead of P and O, sodium and then sulfate instead of S and O. Same on the other side. Now we're going to solve this the same way we approach every problem. We're going to write down the number that we have. We have 3 coppers, 2 phosphates, 2 sodiums, and 1 sulfate. On this side, we have 1 copper, 1 phosphate, 3 sodiums, and 1 sulfate. Now we're going to go line by line and balance these. Copper, there's 3 on the left and 1 on the right. I can multiply 1 by 3, and that's going to equal 3, and I have to go up here and make this true. Now, because I have 3 coppers, those are attached to sulfates, so I also have 3 sulfates. Now we go to the next one, phosphate. On the left I have 2, on the right I have 1. Multiply 1 by 2, make this a true statement up here, and then update my number of sodiums to 6. Move on, copper is good, phosphate's good, sodium. 2 on the left, 6 on the right. I can multiply 2 by 3 to get to 6, and then up here I have to make that true. I have 3 times 2 is 6. Now I have to update my sulfates to 3. And this equation is now balanced. There are 3 coppers on the left, 3 on the right, 2 phosphates on the left, 2 on the right, and so on. For the last example, I'm going to give you a trick that's very useful when you're moving through chemistry. For this one, H2SO4 plus boron hydroxide leads to boron sulfate and water. Now, solving like this can be difficult because it seems like we have SO4 on each side, but we don't have OH on each side. And this is where I'm going to give you a trick. You can rewrite H2O as HOH. That's still 2 H's in an O, and this is perfectly acceptable. This makes the problem easier to solve. So on the left, I have H's, I have SO4s, I have B's, and I have OH's. On the right, I have the same. Now we're going to write down our numbers, and we're going to try to balance. I have 2 H's on this side, 1 SO4, 1 B, 3 hydroxides. 1 H, 3 sulfates, 2 borons, 1 hydroxide. Take a moment to try to solve this problem on your own. Okay, let's begin. First, let's balance the H's. There's 2 on the left, 1 on the right. We're going to multiply by 2, go up here, make this true, and update my number of OHs because now I have 2 of them. H's are balanced. SO4. 3 on the right, 1 on the left. Let's update this. 3. Make that true at the top, but then I'm going to have to go back and actually update my number of H's. I actually have 6 now. Well, I can fix that. If I have 6 now, I can multiply 1 by 6. And then just update my number of OHs. Okay, now my H's are balanced, my SO4s are balanced, onto my borons. Boron, I have 2 on this side, 1 on this side, so I can multiply 1 by 2, go up to my equation and actually give myself 2 borons, and then I see that my number of OHs have updated. I have 3 per boron hydroxide, but I now have 2 boron hydroxides. And you will now see that all of these are balanced.